Hello guys, welcome back to Tronics Energy and a happy new year to you guys. It's 2025. Like, how cool is that, man? I'm really excited. Last year we did some quite cool projects and there were a bit of challenges here and there, but for this year I'm really hoping that we are going to learn a lot with you guys. We are going to do a lot of experiments. We are going to learn a lot about building circuits on our breadboard and building even more complex circuits than the ones that I did last year and the other year previously. So we are going to continue from where we left. Remember, we are still in our series of making the 8 by 1 logic unit, and what it will be doing 8 different logic operations, and it will start with the AND, OR, NAND, NOR, XOR, XNOR, not A, not B, and those are the logic operations that it will be doing. So if you can remember the last video that I posted, it was about connecting these two ICs, these two multiplexer circuits that are in this IC. Remember, this is 74153, is IC 74HC153. It has two multiplexers like this. You see, this multiplexer has 4 inputs, 1 output, 2 select lines, and 1 enable pin which has an inverted section there. So this IC has 2 circuits like this. So we already finished the first one in our previous videos. It had data lines from pin number 10, 11, 12, 13. Those are the data lines, and we already finished up connecting them. Then we are today going to start, because I showed you how you can connect these two multiplexers to make it an 8 by 1, since both multiplexers has 4 inputs. So if you add those 4 inputs with the other 4 inputs, it will be 8 by 1 multiplexer circuit. So last video I showed you how to connect them. So today was to start connecting the other line. It's like we are starting again on the other multiplexer. So the other multiplexer will be using K. So K naught will be our first logic operation, and it will be XOR. Yeah, as you can see, we have also added the select head 2. Initially we were using 2 select lines. If I can just cover this, so these are the select lines, not counting this K naught. From here, these were the select lines that we had in our previous videos, because we were connecting a 4 by 1 multiplexer, and I said 4 by 1 multiplexer has 2 select lines. For an 8 by 1 multiplexer, if you can remember, I said it has 3 select lines. So we are going to add another binary before those. We are going to add another binary before those that we had to make them 3. So if it's AND, it will be 0, 0, 0. If it's OR, it will be 0, 0, 1. If it's NAND, it should be 1, 0, 1, 0. NOR will be 0, 1, 1. Then XOR will be 1, 0, 0. So this is the binary of 0, this is the binary of 1, this is the binary of 2, this is the binary of 3, this is the binary of 4, and we are going to go up to binary of 7, which binary of 7 is 1, 1, 1. Okay. Yes, I hope I'm not too fast. So yes, so today we are going to start with our K naught and our K0. K naught, it will be doing XOR operation of A and B. Okay, so the IC is right here. This is the integrated circuit. It's a 74HC86. It has 4 XOR gates, so we are just going to use 1, and it has inputs A and B, and the output pin number 3 enters the multiplexer. So since we are making an 8 by 1 meaning it has 8 inputs and 1 output. So since the output is 1, you can see I've added diodes. Why? Because this LED will be receiving information from 2 different parts. It will be receiving information from the top multiplexer, the output of the top multiplexer. Then it will also be receiving information from the bottom output of that multiplexer, this multiplexer. So why we are using diodes? When this is on, then that one won't interfere with this other part of the circuit, because this is forward biased. The diode here is forward biased, meaning that current can only come this way and cannot go back that way. And if this has current can only go this way, cannot go back that way. So that's just for the protection. Yes, so we are using one LED, since it's an 8x1, so definitely the output should be 1. Doing all those operations, it will be showing you in a single LED. That's why it's a 8x1 multiplexer, or 8x1 logic unit. So these are the LEDs. These are the LEDs, and they represent this the let me see. This is the first LED, second LED. This is 0, S0, S1, S2. Yes, S2. So the S2 is the one that we have added. Initially, we were dealing with only these first two ones. Then we have added this other one, this section, this section here. So that's how our circuit will be. And yes, so we can check it out, and we can see how it operates. So for an XOR operation, let me show you the truth table. The truth table of an exclusive OR goes like this. If both inputs are 0, you'll get a 0 output. If both inputs are 1, you'll get a 0 output. The only time you'll get an output is when there's a 1, the inputs are varying. There's a 0, 1, or there's a 1, 0. If the inputs are varying like that, then you'll get a 1 output. But when both inputs are alike, you'll get a 0 output. So that's basically how an exclusive OR gate will be operating. So let's check that out. If I can just place this here for us to see if our circuit is behaving like that. I hope you can see. Then I'll use this screwdriver to turn on this circuit. So already it's on. Already our circuit is on. I hope you can. Let me just try to place it on top like that and turn my camera. Yes. So this is our circuit right there. Yes, so already it's on, and when it's on like that, all inputs are 0, the select lines are 0. When the select lines are 0, meaning that it has chosen AND operation. And AND operation is 0. Why? You can see the output is 0. Why? Because for an AND gate, if I can just turn this, to see, for an AND gate, we say the only time there will be an output is when both inputs are on. So when both inputs are on, you'll get an output. So let's see. So because it's an AND gate, when I put these inputs, all of them on, we expect an output. So turn A, yes, you see there's an output. If either of the input is on and the other one is 0, it will just give you a 0 output. So if I turn this off, 0 output. If I wanted to turn this other one off, you get a 0 output. So the only time you'll get an output is when both inputs are on. So enough of that. Let's shift to our interest of the day. So our interest with this exclusive OR. So when both inputs are 0, you get a 0 output. So we should first give the code of XOR. The code for XOR is 100. So let me turn this on. Yes. Now the circuit has shifted from all other operations to be dealing with only a XOR operation, because the select, we have given it the code for XOR, which is 100. So now we can go to our table. When both inputs are 0, you'll get a 0. When both inputs are 0, you'll get a 0 output. When either of the input is 1 and the other one is 0, you'll get, or if the inputs are varying, you'll get a 1 output. So let's put A on and check. Okay, okay. So when A is on, you get an output. So A is on, B is off. Okay, so let's turn on B now and turn off A. Turn on B. So when we turn on B, you'll see there's an output and A is off. And the last one, when both inputs are on, you'll get a 0 output. So let's turn on A. Turn on A. You get a 0 output. Just yeah, like that. You get a 0 output when both inputs are on. So we said for exclusive OR, for XOR gate, if the inputs are alike, you'll get a 0 output. So because they are 0, 0, they are 1, 1, you get a 0 output. If we go back and turn them off, you get a 0 output. So that's how our XOR gate operates. And the code that you have given it is 100. So if you put any other code, then it won't function as the XOR. It's going to function as another, like let's say we put, let's choose, let's do OR gate, or for OR operation the code is 001. It's actually it's actually looking the opposite of it's actually the opposite of that. So let's turn off these and turn on that. So 001, now it's at OR gate. OR gate, if you can remember, OR gate is right here. If either of the inputs is 1 or if both of the inputs is 1, it's going to give you a 1 output. So if either of the input is 1, going to give you a 1 output. If either of the input is 1, you're going to give you a 1 output. Or if both of them are 1, you get a 1 output. So that's OR. So now we have added an XOR today, and the code is 100. So I hope we are going well. I hope I'm not going too fast. If I'm going too fast, you can slow or you can rewind and try to understand where you have not understood. So our circuit is continuing to grow. You can see a lot of wires, but for new viewers, we it's not complicated as it looks. If you can just go to my page and just check where we started and how we started, you're going to see it's not complicated as it looks. Yes, even the couple of videos to come, it's going to be more complex than this. It's going to be looking like a lot of jumper wires here and there. It's going to be looking like it's hard, but it's not hard. It's just easy. It's just easy. So thank you very much guys for watching. Next time we are going to go to an XNOR gate, and we don't have an IC for an XNOR gate, but we are going to make it because the logic gates here are enough to make. I think for an XNOR gate you need a NOR gate, an AND gate, and I think an OR gate to make the XNOR. But we are going to check on that later. So for today, this is what I wanted you to see, and I hope it was helpful. So thank you very much guys for watching. Please subscribe to Tronics Energy, where we do fun stuff all day, all time. Hope to see you next time. Goodbye.